Okay, welcome back to our next objective. Dealing with slope and another equation. So we're going to kind of steer away from slope-intercept form and move into point-slope form. And again, in years past, we would say, oh, you got to memorize this. This year, you don't have to worry about it. We just want you guys to be successful with this and make sure that you know how to use it properly. So point-slope form is our new equation we're going to use, and it does have its perks. You don't need a y-intercept to graph it. You just need a point and a slope, and it's very useful for solving in trying to get y by itself if you're given 2 points. So let's just kind of compare point-slope form to slope-intercept form. So we know the slope-intercept form is y equals mx plus b. That's slope-intercept. And from this form, we could see that m is your slope and b is your y-intercept, which is the coordinate 0, comma, b. Now, point-slope form is defined a little differently, but that m, that's still going to be there. So the same m in point-slope form is the same n in slope-intercept form. And so m is your slope. And then x1 and y1, this is like the beauty of it, are any points on the graph, or any point on the line. So it could be the y-intercept, or it could just be any point that's on that line. And again, there's an infinite number of points on the line. So you don't have to like pick just one. You have an infinite amount to choose from. So now our first job is to be able to write an equation in point-slope form. And the big thing, and again, in years past, sometimes kids would forget that it's minus x1 and minus y1, but you guys don't have to worry about that this year because you guys have the formula at your disposal. So m is equal to negative 2, comma 4, comma 2. This is my x1, this is my y1, and this is my m. And so in order to write this equation, it's just going to be y minus 2 is equal to negative 2, parentheses, x minus 4. And leave it. I know it's very tempting to distribute that negative 2 because you see it with parentheses and you're like, I know I got to distribute. I know I got to distribute. Just don't. You don't have to distribute. Just leave it. This is the correct point-slope form. Now, plotting, I think it's kind of easier because you don't need necessarily the y-intercept. You just got to plot this point first, 4, 2. So 1, 2, 3, 4, 1, 2. So plot 4, 2 first, and then use your slope, negative 2, and write the equation and find the second point. So down 2 over 1 and down 2 over 1. And if you want to get to the y-intercept, you could. You don't need to. Okay, well, we're not going to see it here, but eventually we'll get to it. And there's the equation and there's the graph of the line. All right, let's try this again. So here, m is 3 halves. This is my x1, this is my y1, and now I'm going to write the equation. So y minus parentheses negative 7, don't forget that, equals 3 halves parentheses x minus parentheses negative 5. Now, since we're still learning this, I'm using those parentheses there, but I think some of you guys are going to automatically say, well, isn't it, if it's the opposite of a negative, isn't it just positive? And you're right. You could just go right ahead and say it's y plus 7 equals 3 halves x plus 5, right? And this is the correct form. So now when we're working backwards, you got to remember that if it's a plus here, that means it was originally a negative. So that's something that will come into play real soon. But just know that in the original form, it's y minus y1, x minus x1, and then when you're given those coordinates or you're given the equation, you got to work backwards and remember it's change the sign. So now let's go ahead and plot this. So negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, and up 3, 1, 2, 3 over 2, up 3, 1, 2, 3 over 2, up 3, 1, 2, 3 over 2. So here's where, again, point-slope form is kind of nice. Notice that your y-intercept here is not an integer. or in other words, it's not 1, 2, 3, 0, -1, -2, -3. It's some fraction or some decimal, or it's just a number that is in between the integers, and I don't know what that number is. But if you had to graph it using this y-intercept, you would have a hard time because you're like, well, where is 1.2? Is it up? Is it closer to 1? Is it in the middle? It's not going to be very accurate. However, this is very accurate because it doesn't rely on the y-intercept. All right, one last thing before we try some more problems here. If you're looking at point-slope form, you're like, Mr. Basso, that looks kind of familiar. You're right, because if you just rearrange it, let's say you solve for m is equal to y minus y1 all over x minus x1. It is just the slope formula, except that we put the x minus x1 on the same side as the slope, as the same side as the m. So if you're like, oh, those numbers look familiar. Yeah, you're right. It's a slope formula, basically. All right, so now we're going to work backwards here. We're going to look at the equation, and we're going to write down the point and then write down the slope. But remember, it is the opposite. So it's the opposite here and the opposite here. Opposite, 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 opposite. So the point would be -6, +4, and the slope is -2. This point would be +5, -6, and the slope is -1/3. And this point would be -1, -3, and the slope is -4. All right, so it's the opposite of what you see there. And hopefully, and this is, this could happen if you're rushing or whatever, x is with x and y is with y. So when you're writing as your xy coordinate, make sure you put the numbers in the correct spots. Okay, so now we're going to plot. So -6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. That's my point. Down 2 over 1, down 2 over 1, down 2 over 1, and there's my line. Over here, 5, -6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and then down 1 over 3 off the graph, but that's fine. We can go up 1, left 3, up 1, left 3, oops, 3, okay, and there's my line. All right, over here, -1, -3, and down 1, 2, 3, 4, 1, up 1, 2, 3, 4, 1. There's my line. All right, so maybe I'm convincing you guys that the point-slope form is nicer than slope-intercept form, which it's fine. They're both great, right? But this one does have some other perks to it. All right, so given the following information, write in point-slope form. Okay, all right, well, look at the information. All right, I'm given a slope, I'm given an x1 and a y1. So how do I write in point-slope form? Well, first, know the form. Y minus y1 is equal to m times x minus x1. So now substitute into the form. So y minus -6 is equal to -4 x minus 4. Y plus 6 is equal to -4 x minus 4. Resist the urge to distribute. Over here, x1, y1. Y minus 6 is equal to 5/3 x plus 2. See what I did there? I just went ahead and wrote the opposite. All right. Now, let's try this again. Looking here, yes, I know you can write it, and now you're probably like, oh, I can write this in slope-intercept form. Yeah, that's great. Yeah, I know. The y-intercept is there, and the slope is up 1 and over 1, 2, well, not over 3, up 1 and over, up 2 over 1, 2, 3, 4, 5. So, I know you can write in slope-intercept form, but we want you to write in point-slope form. So now let's just pick a point. You could pick the y-intercept, or you could pick this point. Doesn't matter. Okay, let's just use 5, 1. And your slope is 2/5. And now my equation, y minus 1 is equal to 2/5 x minus 5. But let's say you're like, you know what? I like y-intercepts. That's okay. You can use your y-intercept. This point is 0, -1. So your equation would be y plus 1 is equal to 2/5 x minus 0. They're both correct. That's the nice thing about this form, is there's an infinite number of correct answers. This is correct also. So if you, whatever point you picked is fine. All right, now, this is kind of a trick question. This is an x equals equation. You can't write it in point slope form. But I know that we still need help with this. And the answer is not undefined. That's the slope. I want the equation of the line. Well, I got to look at all these points here to get a pattern. So -1, 0, -1, 2, -1, 3, -1, -1, -1, -5. All that we have in common, x equals -1. All right, so now comes the fun part. We got to do a little bit of work. Remember, it's y minus y1 equals m times x minus x1. So I need two things. I need a slope and I need a point. Well, looking at these problems, E and F and G and H, I have points. That's not a problem. What I don't have is a slope. So now I got to use the slope formula. M equals y2 minus y1 all over x2 minus x1, x1, y1, x2, y2. Let's find the slope first. So 5 minus -6 all over 2 minus 4. M is equal to, that's 11 over -2 or -11/2. Either one is fine. Most likely, though, this is easier to use. And now you're going to have, again, there's an infinite number of answers, but now you just need to pick one of these and you can write your equation. So, I think having two positives is a little bit easier than having a positive and a negative. So I'm going to go ahead and write my answer as y minus 5 is equal to -11/2 over x, or times x minus 2. Okay, so that's the correct answer. However, if you're like, you know what, I like keeping it as x1, y1, that's okay. Y plus 6 is equal to -11/2 x minus 4. This is also the correct answer. So there's going to be an infinite number of correct answers. The only thing you have to do first is find the slope. So let's do this again. M is equal to x1, y1, x2, y2. So 1 minus 5 all over -1 minus 0. So that's -4 over -1, which is 4. And now pick a one. It doesn't matter. So I'll pick the first one. Y minus 5 is equal to 4 times x minus 0. But if you like the second one, that's fine too. Y minus 1 is equal to 4 times x plus 1. Either one, totally fine. All right. Now, with slope here, you guys have done a really good job of just kind of following this pattern. So we could continue doing that. To go from -2 to -3, that's -1. And to go from -1 to +3, okay, that's 4. Okay. So now my slope is -1/4. And I could pick any of these to write my answer. So in the sake of time, I'm just going to pick one. I'll pick the first one. Y plus 2 equals -1/4 x plus 1. And that's it. Okay, let's try this again. Again, you guys have done a really good job of just figuring out the slope from here. But remember, it's y, change in y over change of x. So to go from 0 to 1, it's +1. And to go from 5 to 2, that's -3. So my slope is -1/3. And to find the equation, I just pick any of these. This time I'll just go with 2, 1. Y minus 1 is equal to -1/3 x minus 2. But you could pick any of these and it would work. Okay, so now this is kind of like the true power of point slope form, is we can change it to slope intercept form pretty easily. And the reason we want to do this is because sometimes it is easier to graph it in slope intercept form. So let's do that. Y plus 7 is equal to 2 times parentheses x minus 4. So we're going from point slope form to slope intercept form. Or in other words, solve for y. So let's solve for y. Distribute, distribute. Y plus 7 is equal to 2x minus 8. Subtract 7, y is equal to 2x minus 15. Okay, and what's my y-intercept? Well, I can get it from here, 0, comma, negative 15. All right, let's try this again. Distribute, distribute. Y minus 3 is equal to negative 4x minus 28. Add 3 to both sides. Y is equal to negative 4x minus 25. Find the ordered pair. So that just means substitute 5 in for x and solve for y. Y is equal to negative 4 times 5 minus 25. Y is equal to negative 20 minus 25, which is negative 45. All right. Now, find the x and y intercepts of the line below. Okay, this is almost in itself a new topic, right? But we're going to continue it here, and I'm doing really good on time, so the video is not going to go that much longer. The way that this is written here, these two equations, this is another form, and this is called standard form, or ax plus by is equal to c. A standard form is actually pretty useful for real life problems. Like if you want to say I have $5 worth of peanuts and $7 worth of walnuts, and the total amount is $80, you could figure out the quantity of how many combinations of peanuts and walnuts you would get in order to figure that out. So it's really nice for real world problems, and you'll learn in the next unit about something called systems of equations, and these are really nice to work with. Now for graphing wise, they're also really nice because you could graph these with just intercepts. And this is like the big idea that we need to take away from this. And even my seniors still struggle with this. Okay, and I'm on record saying this, so you can play it back to them. An x-intercept has a y value of 0. And that's where it crosses the x-axis. So if I want to find an x-intercept, all I got to do is substitute 0 in for y and solve for x. A y-intercept has an x value of 0, and it crosses the y-axis. And that's why every single time that I write a y-intercept, I always put 0, comma, whatever, because the value is 0, like I did up here, 0, comma, negative 15. All right, the x value is 0. So if I want to find, I'm just going to make a little graph here. If I want to graph this, I could graph it using intercepts. And in order to find these intercepts, I just substitute y for 0 to find the x-intercept and x for 0 to find the y-intercept. So, just a little organized chart here, x-intercept, y-intercept. Now what makes this really nice to work with is by putting in 0 for y, now I don't have that y value or that 5 anymore. My new equation is just 3x equals negative 15, x equals negative 5. A little mental math. So that's negative 5, 0. To find my y-intercept, I plug in 0 for x. So 3 times 0 minus 5y is equal to negative 15. Negative 5y is equal to negative 15. Y is equal to 3. 0, 3. And now to plot this, I just plot these points on the respective axes. So 1, 2, 3, 4, 5. 1, 2, 3. And there's my line. And this is the line 3x minus 5y equals negative 15. So you could solve for y, right? I'll show you that. You could, right? So that would be negative 5y is equal to negative 3x minus 15. Divide by negative 5, divide by negative 5, divide by negative 5. Y is equal to 3/5 x plus 3. And you see, plus 3, 0, 3. You see that, right? but you don't have to. That's the nice thing about standard form, is you don't have to solve for y if you understand the x and y intercepts. Okay, let's try this again for b, right? You pause the video, you guys can try it. I'm gonna go ahead and finish it to respect your time. So make a little chart. And that means, remember, x-intercept means that y is 0, y-intercept means that x is 0. So all I'm going to do is plug in 0 for y. So that's 2x minus 0 equals 20. 2x equals 20. X equals 10. So my x-intercept is 10, 0. And my y-intercept, well, that's 2 times 0 minus y equals 20. Negative y equals 20. Y equals negative 20. 0, negative 20. And again, since I made this sketch myself, it's pretty easy to just go ahead and say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wrong way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And there's my 2 points, and there's my line, right? And if you solve for y, again, you get y, if you get y by itself, so that would be negative y is equal to negative 2x plus 20, divide by negative, divide by negative, divide by negative, y is equal to 2x minus 20. Okay, so you could solve for y if you want, but with the intercepts, it's not too bad. All right, that's kind of like a little secret there. So now you have 3 ways of graphing: slope-intercept form, point-slope form, and now, just briefly, standard form. Okay, we'll see you guys in class. Have fun.